This is my second isolating transformer. The other one is already over there, sitting nicely down. Even though I still don't understand that green wire on the input side, but that's just what it is. I mean, I understand it, I just don't understand it as much as I want to. So I'm making this video because not just that this green wire is on the output side only, but this also has capacitors and I don't know what the values are yet, and this beige looking round thing that if I understand right, those are, I have quite a few of those at home. They are automatic resettable fuses. They automatically reset after they cool down. So this must be some kind of a protection. It's between the hot and the ground. And so I really don't understand quite how this works, because I always thought that that would shorten things, but maybe this works the other way around. When too much current goes through, then it opens up or something like that. So anyway, so this green wire, which is about roughly in the same spot as this white wire that I put this green on, because it is also having a green connection, which is there's basically two wires connected to the ground, to here as well as from here. And these, both of these, they kind of look like a center tap or something. They kind of in a center. Then there is this black wire, which was white, and I put a black on it so I can put it back together the way it was originally, is right here at the edge. Now, I have also, it came damaged, so like this came busted, the case came busted, and then this wire here was disconnected. So I'm going to show you the other side. So this is where the input is, and so from the cord, the green wire goes to the chassis, and everything is, by the way, there's 4 green wires here on the bottom, and then the black wire goes to fuse, which is correct way of doing it. Then the black wire goes over here to the switch, and this switch has three connections. The reason it has 2 black and 1 white is because there's a bulb inside this switch that's supposed to lit up when you turn it on. So that's the reason why there is this white wire, which is, by the way, coming from the input side. Okay. So then the switch continues when you turn it on, and it goes over here, which was also a white wire, but I put black on it so I can put it back to the same spot. And I'm going to redo this broken connection where nothing but 2 white wires are connected at. So that's just how this is how this is done, how this is connected. I don't understand why on the other transformer the input has this green wire, and here is on the output side, and then they put the neutral wire onto ground as well on this side. So I'm a little confused about it. The front of this transformer is has 2 plugs, US plugs, and then this is where this resettable fuse would have been if it didn't break off, but I'll replace it. And it is a model IS250 isolation transformer, 120 volts, 2.2 amps, 60 hertz, 1 phase, and it's made by a Triple Manufacturing Company in Chicago, Illinois. That's what this label says. It also has a high point pass, which who knows what it is. And then I just wrote down in here how the wires were connected, just to make sure that I connected correctly. On the back, the only thing it says triple light, the power people, and then ISO Lentor is some kind of a mark down here. So I think the company is called Trip Light, but I'm not 100% sure, since on the back in here, as I read it earlier, it's a Trip Manufacturing Company. So they just use different names. This meter here is in a Unit T UT70B. My twin brother died 2 years ago when I got this meter, because that's the one he used every day. And then I have a Fluke 289 on here on the right side, and I have both. I have this one connected to calibrate the probes, and I'm getting 0.08 ohms, so that's pretty good. And then on this unit D, I have it set it up to do a connect, so I can tell if the wires are like connected. Like for instance, this winding and this winding are connected, you know. So I'm going to use it for that purpose. Now I'm going to go ahead and give you the measurements. So if I take this probe and put it on the input wiring side and put it the second wire here, I'm gonna get about 1.26 ohms. So minus 0.08 would makes it 1.16. I'm sorry, 1.18. It would be the true reading of this. I'm gonna pause this video for a second.